Hi, I'm Taeyoung, and I am the speaker of the poster Automation Methodology for Bus Performance Verification using IP-XACT. First, let me talk about what the bus performance verification is. The bus performance verification is to measure the performance of every DMA masters in the SoC. We aim to measure how the latency, bandwidth, and more are affected by the bus components, for example, memory management unit, arbitration unit, or whatever the data transaction must go through to get to the memory. There are hundreds of DMA masters in the SoC, and the test must be done for all of the masters, which takes a huge amount of time. To reduce the test time, we use a traffic generator which replaces the real masters. Compared to the real DMA masters, TG does not require any vectors or firmwares to make data transactions. So, TG is a perfect solution for the test, which has a lot of verification targets, just like the bus performance test. But still, there is a problem. No matter how convenient TG is, there are hundreds of verification targets in the SoC, so TG replacement itself takes a lot of time. Also, TG replacement requires some manual work which can cause human errors. To solve this problem, we made an automation methodology for the TG replacement. We expect to reduce the verification turnaround time by automating all of the manual works. The methodology requires two inputs. One is the bus specification document, which determines the traffic information, for example, the burst information, AXI ID or user bits, minimum bandwidth, and guaranteed maximum latency. The other is the DUT information, which is surely provided by the IP-XACT. As a result, two files are generated. One is the TG database file. It describes what masters are replaced by the TG. This file contains signal list of the master's data protocol, where TG invokes the data transactions instead of the real masters. The other is the TG configuration file. This file contains the traffic settings that TG must follow. These two output files are used for the emulation image build. After the emulation image build, we can see the real masters are replaced by the TGs based on the information in the TG database file. When we run the emulation image, TG starts to make the data transactions based on the settings in the TG configuration file. The methodology is divided into three steps: extraction, find intersection, output generation. At the extraction stage, two input files are read and extracted. From the bus specification document, the location of the verification targets and traffic configurations are extracted, and from the IP-XACT, data interfaces are extracted. At the find intersection stage, the methodology tries to search the verification targets from the IP-XACT. If the verification targets are not found in the IP-XACT, the methodology reports to the user that it is not appropriate for the automation. At the output generation stage, which is the last step of the automation, output files are written. We applied this methodology to the test environment for the development. Test was done for the 190 masters, and the automation methodology successfully generated the outputs. 176 masters were automatically processed. 24 failures mean that some of the IPs are not found in the IP-XACT because the IP does not support IP-XACT, which will be fixed very soon. Surprisingly, the 2 weeks of manual works are reduced within a minute. With this methodology, we no longer suffer from the human errors because we don't have any manual works. We saw the full-sized SOC is easily handled with the IP-XACT, so we are now trying to automatically process other verification IPs, something like AVIP or XTOR. In conclusion, we successfully developed the automation methodology with the IP-XACT, and this automation methodology will be applied to an upcoming SOC project. Thanks for the listening.